Okay, so yesterday we looked at absolute value equations. We're going to do some more with them today. So if I'm going to write the expression absolute value of w plus 4 equals 3 in words, we're thinking about distance, and distance is found by subtracting two values. So let's write this as minus negative 4, because that'll give us an expression that it's more easy to think about. It gives you the distance between w and negative 4. So that says the distance between w and negative 4 is equal to 3 units. So if I draw a number line to solve this, think about the value we know is negative 4, and we know that to get to w, we need to go 3 units in either direction, because we know the distance between negative 4 and w is 3 units. So I could go 3 units bigger than negative 4, which puts me at negative 1. Or 3 units smaller than negative 4, which puts me at negative 7. So the two numbers that are possibilities for w, the ones that are exactly 3 units away from negative 4, are negative 7 and negative 1. One thing we didn't look at was just evaluating an expression that has absolute value. So if you're evaluating this when a is negative 2, you need to replace your variable with negative 2. Like always, when you plug something in, make sure you put it in its own set of parentheses. And then absolute value bars are a grouping symbol, like parentheses, except they're kind of special. You have to work inside them first. You can't multiply negative 3 in. So working inside, you'd have 16, and then 16 minus 3 would give you 13, and then you could multiply negative 3 times the absolute value of 13, which the absolute value of 13, distance between 13 and 0, is just 13, so you end up with negative 39. We're going to talk about how to solve absolute value equations algebraically, so you can do them without a number line. If it's a more complicated one, especially, it might be a little bit easier. So how it works is we want to get the absolute value part of the equation on a side by itself, and then we write two equations and solve each one of those. Key is you have to check your answers to make sure they actually work in the original. If they don't work in the original, they are called extraneous solutions. Fancy vocabulary word. Okay, let's solve a couple with algebra. So if you are starting this one, you want to get the absolute value part of your equation by itself, so subtract 1 from both sides. And you'd have the distance between k and 6 is equal to 3. So what you could do if you're solving this with algebra is write two different cases. So whatever's inside your absolute value could be equal to positive 3, because absolute value of positive 3 is 3. Or it could be equal to negative 3, because absolute value of negative 3 is also equal to positive 3. So if you solve both of those equations by adding 6 to both sides, you're going to end up with, looks like k equals 9 and k equals 3. We do need to check these in the original to make sure that they actually work, so let's try 9 first. So plug it into your original equation. You got the absolute value of 9 minus 6 plus 1, and we're trying to see if that equals 4 or not. Absolute value of 3 plus 1, and then 3 plus 1 is in fact 4, so 9 works. We need to do the same thing with 3, so if you plug it back in, run through a quick little check here. You do need to make sure you're in the original equation, because otherwise it might seem like it doesn't work, but it does, because when you take the absolute value of negative 3, you get positive 3. So those do both work, and you have two solutions to that one. Let's try another one. You have variables on both sides, which doesn't really change anything. This would be a harder one to do with the number line, though, so algebra is a little bit easier. So you could have x plus 3 be equal to positive 2x, or it could have its sign flipped, because the absolute value of either one would still make your equation true. So if you subtract x from both sides, I'm kind of doing these simultaneously here, you get x equals 6, and then if you divide by negative 3, you get x equals negative 2. So those look like our two possibilities, but like always, absolute value equations, we need to check. So if I plug 6 back into both sides of my equation, see if those are truly equal to each other, I got the absolute value of 12 equals 12. Yeah, that's true. If you try -2, plugged back in, then on the left side you've got the absolute value of 4 equals -4. The absolute value of 4 is just +4, which is not equal to -4. So that solution was extraneous. The only true solution is x equals 6. Now on this one, you would want to get the absolute value part by itself by dividing by -2, because absolute value bars aren't the same as parentheses. The distributive property does not hold. You cannot multiply that in. So divide both sides by -2. Now you could write two equations from this point and solve them both, plug back in, check, or you can notice, if you actually think about what this means in terms of distance, this says the distance between x and -3 is equal to -3 units. I can't have a distance be equal to a negative value. So if you reach any point like this, you know it's going to be no solution.